Hello friends, this video on motion and time part 11 is brought to you by examfear.com. No more fear from exam. Question number 6. Salma takes 15 minutes from her house to reach her school on a bicycle. If the bicycle has a speed of 2 meters per second, calculate the distance between her house and the school. So let's say this is her house and this is her school. So we have to find out the distance between the two. So the time taken by her to reach her school is 15 minutes and the speed of her bicycle is 2 meters per second. So the speed is given as 2 meters per second and time taken is given as 15 minutes. So 1 minute is equal to 60 seconds. So 15 into 60 seconds. You can convert it from minutes to seconds. So this is going to be 900 seconds. So now we know that speed is equal to distance by time. So therefore we can say distance is equal to speed into time. So that is equal to 2 into 900, which is equal to 1800 meters, or we can write it as 1.8 kilometers. So this is the distance between her house and the school. Question number 7. Show the shape of the distance time graph for the motion in the following cases. A car moving with a constant speed. So the speed of the car is constant. So the car is moving and the speed is also constant. So in distance time graph, this is the distance and this is the time. So any car moving with a constant speed is nothing but uniform motion. And how the graph looks like in uniform motion? So this is how the graph would be. It would be a straight line so that it covers equal distances in equal intervals of time. A car parked on the side of the road. Parked on the road means no motion. The park is not moving at all. The car is not moving at all. It is at rest. So in the second case, if this is distance and this is time, so this is how the plot would be, because the distance, value of distance would not change with increase in time. Question number 8. Which of the following relations is correct? Speed is equal to distance into time. Speed is equal to distance by time. Speed is equal to time by distance. And speed is equal to 1 by distance into time. So speed is always distance per unit time. So second one is the right option. Question number 9. The basic unit of speed is kilometer per minute, meter per minute, kilometer per hour, meter per second. So the basic unit would be meter per second. That's because, as I have mentioned before, that speed is distance per unit time. And the SI unit for distance is meter and the SI unit for time is second. So therefore the basic unit for speed would be meter per second. Question number 10. A car moves with a speed of 40 kilometers per hour for 15 minutes. And then with a speed of 60 kilometers per hour for the next 15 minutes. So the total distance covered by the car is, so here as per this question, it says that for the first 15 minutes, so the first 15 minutes, the car moves with a speed of 40 kilometers per hour. The next 15 minutes, it moves with a speed of 60 kilometers per hour. So we have to find out the total distance. So let's say that for the first 15 minutes, the distance traveled is d1. For the next 15 minutes, the distance traveled is d2. So we have to find out d1 and d2 and then we can add them together to find out the total distance. So what would be d1? So distance will be equal to speed into time. So what is the speed? Speed is 40 km per hour and time is 15 minutes. So we will convert this also into hours. So 15 by 60. So this would be 4. So this is equal to 10 kilometers. Similarly, let's find out d2, which will be equal to speed into time. Speed is 60 km per hour and time is again 15 minutes, which is 15 by 60. So this would be 4. So this would be again 15 kilometers. So D1 and D2 are 10 and 15 kilometers. Therefore, the total distance would be equal to D1 plus D2, which is equal to 10 plus 15, that is 25 kilometers. So 25 kilometers would be the right answer. Question number 11. The figure shows the distance time graph for the motion of two vehicles A and B. Which one of them is moving faster? Now, how do we get to know the speed of a vehicle from the distance time graph? The slope tells us the speed. Slope, steeper the slope, greater the speed. So, if you compare the slope of A and B, the slope of A is more than the slope of B. So, you just consider any point. So, let's say you just consider this point. You draw a straight line on the x-axis. So this line crosses through this point on A and this point on B. So for this point, what would be the speed at this point? Let's say this is P1 and this is P2. So for P1, what would be the speed at P1? So speed at P1, let's calculate speed at point P1. So speed at point P1 would be equal to distance travelled by time taken. So let's say this is T and let's say this is D. Let's say this is T1 and this is D1. So this would be equal to distance travelled, that is D1 by T1. Now similarly, let us try to calculate speed at P2, that is this point. So this would be equal to this much distance. So this distance is, let's say, D2. So this will be equal to D2 by T1 because time remains the same. Now, if you compare D1 and D2, looking at this picture, you can see that D1 is greater than D2, correct? Therefore, speed at P1 is greater than speed at P2. So that means if you compare any two corresponding points on A and B, the speed for the point which is lying on A will always be more. That means the vehicle A is moving faster. So A is faster than B. So with this, we have reached towards the end of this lesson on motion, and I hope that this lesson would have helped you. So see you all in the next lesson. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.